All right, this is from the 2023 exam, the Taylor polynomial. They've given us some stuff about how the function's behaving. We have f of 0, f prime at 0, the second derivative, and the third derivative. They want us to find the fourth derivative and write the fourth degree Taylor polynomial about x equals 0. Part B, it says the fourth degree Taylor polynomial for f about x equals 0 is used to approximate f of 0.1. Given that my fifth derivative is less than or equal to 15 on these values, it wants us to use the Lagrange error bound to show that the approximation is within 10 to the fifth of the exact value. Part C. Let g be a function so that g of 0 is equal to 4 and g prime is equal to e to the x times f of x. Write the second degree Taylor polynomial for g about x equals 0. So given g of 0 is equal to 4, find g prime if it's e to the x times f of x, and write the second degree Taylor polynomial for g. So recapping what they gave us that f of 0 is equal to 2. F prime of 0 is equal to 3. The second derivative is given by negative f of x squared. Well, f of x squared would be 2, so this would be negative 2. Our third derivative is given by negative 2x times f prime of x squared. So if we plug in 0, this is going to evaluate to be 0. And then lastly, we have to find the fourth derivative. The fourth derivative would be the derivative of this one. And notice that's a product rule. So the derivative of the first piece, copied on the second piece, copied on the first piece, derivative of the second piece, so it'd be the second derivative of that, and then chain rule the derivative of the inside. So if I wanted the fourth derivative at 0, all of this is gone because it has x in it, so this is equal to 0. F prime of 0 is 3, so this would be negative 6. They want us to write the fourth degree Taylor polynomial, so P4 would be f of 0, f prime at 0, x. Then you'll have the second derivative, the second power, the second factorial, the third derivative, the third power, the third factorial, and then lastly the fourth derivative, the fourth power, 4 factorial. And now we just fill in the information we found. F of 0 was 2. F prime of 0 is 3. The second derivative was negative 2, so it could be negative x squared because 2 divided by 2 factorial. The third derivative was 0, so I don't need to write the cubic term. My fourth derivative is negative 6, so minus 6x to the fourth over 4 factorial. So that was part A. Okay, so let's kind of recap what they've given us. So for part B, they've told us that we want to use the fourth degree Taylor polynomial to approximate the error, f of 0.1, and we want to find the error in the approximation. Now notice, this is not an alternating series, so we could not use the alternating series error bound, so we have to use the Lagrange. They've given us a bound for the fifth derivative, and they told us this is the maximum between 0 and 0.5. We know that we're evaluating at 0.1, and our center was 0. So in my mind, what I'm really thinking about is the next term, which would be the fifth derivative at some value, Then we always have x minus c to the fifth power, but here our x is going to be 0.1 minus c, so this would be 0.1 to the fifth power, all over 5 factorial. And if this is Lagrange, we want to maximize this. Now for the Lagrange error, you really only maximize between where you're centered and where you're evaluating. Now, they gave us the error on an even bigger range. So we know for a fact that it's going to be at least smaller. So I know that this is less than or equal to, or maybe not smaller, it might be still that. So 15, and then 0.1 to the fifth is really 1 over 10 to the fifth. And then we had times 5 factorial. And they wanted us to show that this was less than 1 over 10 to the fifth, which I believe everybody can see because 15 over 5 factorial is definitely smaller than 1. Okay, so C. They've given us that g of 0 is equal to 4, and g prime is equal to the e to the x times f of x. So there's a couple ways we can do this. We can immediately just use this. So g prime at 0 would be f of 0, e to the 0 times f of 0, and f of 0 we already known to be 2. Then we can find the second derivative. The second derivative of g would be the derivative of the first, copy down the second, plus the derivative of the second, copy down the first. And if we're plugging in 0, e to the 0 is 1, f of 0 is 2, e to the 0 is 1, f prime of 0 was given to be 3, so that's 5. And it wanted the second degree Taylor polynomial, so this is all we need. So our polynomial for g would then be 4 plus 2x plus 5x squared over 2. So that's one way to do it, and that's not actually the way I saw it the first time. When I saw it, I approached it slightly differently. I looked at g prime, which is e to the x times f of x. And I went through and I figured out what e to the x was. E to the x was 1 plus x squared over 2 factorial. The f of x, which we already had earlier, was 2 plus 3x minus x squared. So we're going to imagine multiplying these together. So our constant terms, we'd have 2. Our linear term, we would have 3 plus, this one times this one, which would be 3. This one times this one, which would be 2. And then that's all the terms we need, because this is really g prime. If I want to go to g, that means I'm going to integrate. So g is equal to 2x plus 5x squared over 2. Now this was an indefinite interval, so you have the constant of integration. And they gave us the constant. They told us g of 0 is equal to 4. So either way, you get the exact same answers. So how was this scored? Part A is worth 4 points. The first point is getting the form of the product rule correct. The second point is for getting the fourth derivative completely correct. The next point is the first 2 terms of the polynomial, and then the last 2 terms of the polynomial. So 4 points. Part B is worth 2 points. 1 for the form of the Lagrange error, and 1 for finding the actual values. C is worth 2 points. Somehow you're either going to find g prime here, or you're going to find g prime by multiplying them. And then the rest of it comes from the first 2 points gives you 1 point, and then the last term gives you 1 point. Bigger